Now this is example number 7th, objective subjective solved example. This equation is given as a degree 4 equation. We have to find all values of a such that this equation has at least two distinct negative roots. This equation will have at least two distinct negative roots. We have to make sure this and find the corresponding values of a. So it's a degree 4 equation, and generally we know how to deal with degree 2 equation, not with degree 4 equation or even cubic equation. We know information about the roots of the degree 2 equation. So we convert this into degree 2 equation, which is an easy task to do. We divide the whole thing by x square, divide by x square, right? And after dividing by x square and combining the terms, it will become x square. Combining this with this, it will become x square plus 1 by x square, and then plus a minus 1. This will become x after dividing by x square, and this will become 1 by x. Taking these two are same, taking a minus 1 common, x plus 1 by x, and then we have plus 1. When we divide this by x square, this becomes plus 1. Now we replace x plus 1 by x equal to t to reduce it to a quadratic equation, and it becomes t square plus a minus 1 into t minus 1 equal to 0. If we solve this quadratic equation, the roots t, which is same as x plus 1 by x, equals to minus a minus 1 plus root of a square minus 1, a minus 1 whole square plus 4 divided by 2. And second case is x plus 1 by x equals to minus a minus 1 plus root of a minus 1 whole square by plus 4 divided by 2. Now see, in this case you can just see the solution yourself. I am not explaining you this case, but if you take this case, we'll get both roots positive, right? So negative roots will come from this side. We have to make sure two negative roots, at least two in this case, like we'll have exactly two negative roots. We'll get exactly two negative roots. So when we take this case, we get both roots positive. When we take this case, we get both roots negative. How we can write this in this form: x square cross multiplication minus, right? This on the side will become plus a minus 1 plus root of a minus 1 whole square plus 4 divided by 2 into x plus 1 equal to 0. Now it's very easy to see that both roots negative. We check sum of the roots, right? For both roots to be negative, sum of the roots is minus b by a, right? This is b. A minus 1 plus root of a minus 1 whole square plus 4 by 2. Product of roots, this is alpha plus beta, is 1. Now you can see product of roots is positive, and you can see sum of the roots is negative. It's very easy to see this number is going to be this is a positive number, right? Because see, this number will be greater than this part. Whatever it is, whether it is positive or negative, this will be greater than this, because this is more than a minus 1. A minus 1, we have a minus 1 equal to a minus 1, right? We write this as a minus 1 whole square, a minus 1 whole square, right? We add 4 to this, so we are making this greater. Fine, and then we take square root, so it becomes a minus 1 less than this. So you can see, so this expression will definitely be greater than this. So it means sum of the roots equal to positive quantity, and there is a negative sign outside, negative quantity. So both roots will be negative provided the roots exist. We check d greater than 0, and we have to make sure distinct negative roots. So last thing we check is d greater than 0, right? and you can also do it like this. You would have done this for both roots to be negative. If I assume this as function f0 should be 0 should lie between alpha and beta for both, 0 should be on right of both the roots for both roots to be negative. So f0 greater than 0, x coordinate of vertex should be less than 0, and d greater than equal to 0. It's the same thing. If you use this formula or this, it's the same thing. Now finally what we have to do, d greater than equal to 0. D greater than equal to 0 means